Chapter 21, Section 2. Chapter 21 is actually the last chapter that we're going to cover for physics, and then we'll start into the chemistry section. So, Chapter 21, Section 2, Electromagnetism. Electromagnetic forces are the forces that you have that result from charged particles. So it's a combination of electric forces, what we talked about in Chapter 20, and magnetic forces, what you should have read about in the first section of Chapter 21. Now, we do have a lot of different devices that we have that are electromagnetic. Electromagnetic devices are usually known as solenoids, so S-O-L-E-N-O-I-D-S. So if you see that in your final exam, for example, it's just talking about something that's electromagnetic. So an electromagnetic device can be something sort of like a galvanometer, an electric motor, a loudspeaker, anything that changes electrical energy into magnetic energy. So electromagnetic, or an electromagnet is a solenoid. And when I say solenoid, I want you to think of a wire that will carry current that's wrapped around a magnet. Okay, so a wire that's carrying current that's wrapped around a magnet. So hair dryers, those have electromagnets. Doorbells, telephones, those all have electromagnets. So a galvanometer is one that is using electromagnet to measure small amounts of currents. So think about your fuel gauge in your vehicle. That's a galvanometer. It's measuring how much fuel is flowing past a certain point in a given time. So that you know kind of what sensor is telling you is how much fuel you have left in your tank. So the needle will move based on that electromagnet. We also have electric motors. These use an electromagnet to turn an axle. And that is where you have a loop of wire, goes through something called the commutator. And as that commutator turns, it changes your current back and forth. So that kind of keeps turning your axle back and forth. Okay. Loudspeakers is another example. It has an electromagnet in there. It works a lot like the electric motor does. However, for this, it increases or decreases to produce music, voices, or any other sound that you want to project. Similarly, your earbuds that you guys are listening to this with, hopefully, those are actually, if you pull them apart, they actually have an electromagnet in them that helps carry the sound from what you're watching into something that you can hear in your ears when we talked about sound back from chapter 15. So electromagnetic devices can convert your electrical energy into some kind of motion, so a vibration that you can hear, a motion that can be followed, so to speak. And that's it for electromagnets. So we're going to go ahead and continue with the last section, Section 3. And this is talking about electrical energy generation and how it's transmitted. So electromagnetic induction is a process of generating current by moving a conductor relative to a magnetic field. So when I talk about an electric conductor, think about those metals. It's got to be a material that charge can flow easily through. And when you move a magnet through that, and there's a picture on page 643 in your textbook, but when you move a magnet through that, it increases the current that's going through it. So it's changing your magnetic field. Now, we have what are known as generators, and this is just a device that converts mechanical energy to electrical energy. You might have a generator at the hospital. There's generators here at the school. You might have a generator at home. I know that we have a generator at our house that has to be kicked in and run. There are two types of generators. There are AC and DC. Both types are pretty commonly used, but majority of like your power plants are going to use AC just because it can reverse that direction of flow. Now we also have transformers, and everybody has a transformer out by their house, because that voltage that's coming in from the power plant is much too high to put directly into your house. So you need a transformer to change that voltage. So a transformer can either decrease the voltage or it can increase it. Going from power lines to your home, it's decreasing the voltage. Now if you'll remember from previous chapters, I've said that the power lines are alternating current. So when it's going from your home, what you haven't been using, back into the power plant as a report, it's increasing that voltage. Okay, because the voltage is not high enough for it to carry quickly. So a transformer is going to change the current by changing the magnetic field in one of the coils. So transformers actually have two coils. They have a primary and a secondary coil. And depending on whether it's a step up or a step down is determining how many loops you have for each one. So for the step down transformers, you have the secondary coil that has fewer turns than the primary coil. And a step up, your primary has smaller or has fewer coils than your secondary coil. Now, your power lines in the United States run about 750,000 volts, but what's actually going into your home is between 120 volts and 240 volts. So that's a huge amount of step down. Now, your energy at your home is generated using coal or hydroelectric. It could be nuclear energy, wind energy, natural gas, or petroleum. Those are the most common types. You'll have a turbine that is going to turn by the water, and that's what we use here. Duke Energy uses water to turn ours. So you can see, if you look at page 647 in your textbook later on, starting from the power plant, you have about 11,000 volts coming out of there. And it gets stepped up so that it can move quickly through those power lines. And then once it moves through those power lines, it has to step down before it can be distributed to your home, to your neighbor's homes, hit a second transformer, and then come into your home. So again, coal, water, nuclear energy, wind, natural gas, and petroleum. And then turbine, you have fan-like blades that are pushed, and they will turn to generate that power. And that's it for chapter 21, and we're done with physics for this semester.